Here's our rectangle and the semicircle with diameter AB. We'll let O be the center of our semicircle, and we'll let X be DA. So we're going to find X. Here's our line L that intersects the semicircle at N, segment AB at U, and segment CD at T. We're going to find the area of the upper region in terms of X, and then set that equal to 1/3 of the area of the rectangle and semicircle, since the two regions are in a ratio of 1:2. We're given that the distance from A to U is 84 and UB is 168. So the diameter of our semicircle is 252. This means the radius of our semicircle, the distance from A to O, is half of that, or 126. I'm going to draw a segment ON, and since this is also a radius, it also has a distance of 126. Let's find the distance from O to U. We'll take that by subtracting AU from AO, so this is 42. In the problem statement, we're also given that the distance from A to N is 126, same as AO and ON. So this triangle, ANO, is actually equilateral. Let me redraw this triangle a little more accurately. And I'm going to draw an altitude from N to side AO. This means the distance from A to H is 63. We have U somewhere in here. This is 42 from up here. So the distance from H to U is 21. We want to find the area of this shape up here, NAU. First, we'll find the area of triangle NOU. We'll use segment OU as our base, and NH is the altitude outside of that obtuse triangle. Since triangle ANO is equilateral, we have a 60-degree angle here. So the distance from N to H is 63√3. OU is 42. This is equal to 21 times 63√3. An AIME hack is not to necessarily multiply these out. Sometimes you'll be able to factor out some factors, saving you time. Now let's find the area of sector NOA. So it's this pizza slice from N down to the center of our semicircle and back up to A, and includes this arc from N to A. Since triangle ANO is equilateral, we have a 60-degree angle down here as well. So this sector is 1/6 the area of the circle that is twice as big as this given semicircle. The radius of that circle is 126, so this is pi r squared. Simplifying a bit, this is 6 times 21 squared times pi. Now we're going to find the area of this shape up top here, NUA. We'll do that by using the area of sector NOA and then subtracting the area of triangle NOU. We'll plug these both in, and we'll go ahead and factor out 3 times 21 squared from both of these terms, leaving 2 pi minus √3 inside of the parentheses. Now we want to find the area of this remaining region inside of the rectangle above line L. I'm going to draw a segment here from U that's perpendicular to DC. I'll call this point V. I'll draw this altitude NH here in our main diagram. Since we have these two vertical sides of our rectangle, AB and DC, are parallel, then this line L is a transversal. So the corresponding angles, angle HNU and angle VUT, are congruent. That's this angle up here and this angle. So now we have two similar triangles. The smaller triangle on the left, triangle NHU, is similar to the larger triangle on the right, triangle UVT. We'll fill in some of these lengths. The distance from H to U is over here, that's 21. The distance from N to H is 63√3. Here we have UV is X, and we'll use these ratios to find the length of VT. So the ratio of these two legs is the same as on the left. And here we have an expression for VT in terms of X. Now we can find the area of the entire upper region above line L. This is bounded by the arc from N to A, and then segment AD, segment DT, and back to N. This consists of the area NUA, including the arc part from N to A, rectangle ADVU, and then the triangle underneath it, UVT. We have this from over here. The height of this rectangle, ADVU, is the distance from A to U, which is 84. So this is 84 times the width, which is x. And then the area of this triangle here is 1/2. The base is VT, so we'll use this, x over 3 root 3. And then the height here is UV, also x, so I'll just put x squared here in the numerator. Since the ratio of the upper to the lower regions is 1 to 2, the area of the upper region is 1/3 r, the area of the rectangle plus the semicircle. Let's calculate 1/3 r now. The area of the semicircle on the left is half of the area of a circle with a radius of 126, and the area of the rectangle, base times height, that's also 126 times x. We'll distribute the 1/3, and we end up with 42 times 63 times pi, and 84x. Now we'll set these two expressions equal to each other, and I'll distribute this 3 times 21 squared over 2 pi minus root 3. The good news now is we have some terms that are the same on both sides, 84x. This term is actually the same here on the left and on the right. So we'll isolate the x squared. We've got a couple of 3's, a couple of 21's, and then 6. So we'll take the square root. This is 63 times the square root of 6. The problem asks for the sum of m plus n, and our answer is 69. If you'd like me to solve any other math contest problems, please leave them in the comments.